So example 3, we're going to talk about the other direction of the process, is the condensing. So in example 2, Mrs. Sachatello was talking to you about expanding, right? Breaking apart the division, breaking apart the multiplication, getting them into separate chunks separated by a plus or a minus in that process. And now sometimes it'll be advantageous for us to express things as a single log. So I like to call the two processes, as I mentioned, expanding and condensing. So the keys with condensing, let's just write down the main key for condensing is that you have no coefficients and you have no addition or subtraction. Because if you're going to condense something into a single log, you can't have your expressions separated by a plus or a minus. And we also don't want things expressed with like 4 times something, because then that implies that there's multiple logs there. We want it condensed into one single log. So this is our key: no coefficients and no plus or minus. And I like to take these things kind of one step at a time here. Okay, so A is going to be 4 times log base 4 of m plus 3 times log base 4 of n minus log base 4 of p. Okay, and before we try to go, I'd say the first step is we really want to kind of tackle each expression on its own. So let's see if there's anything we can condense for each of these, which mainly means can we get rid of any coefficients. So in the first one, 4 times the log base 4 of n. We know that the power property of logs tells us this coefficient can be converted into a exponent. So this will become the log base 4 of m to the 4th. Again, in this second piece, we need to get rid of that coefficient, so plus the log base 4 of n cubed minus, turns out this is just, there's no coefficients, so just the log base 4 of p. And now what we want to do is, now that we have all of them rid of coefficients, we want to look at our log bases, 4, 4, and 4. Which means that these can all be condensed into one. Remember, you can only condense things into a single log if they have the same log base. So the fact that they do, we can go for it. So these two, this operation addition is going to tell us that it's going to be the product of the m and the n term. And then this subtraction tells us that we are going to have division by our p term. Okay, so we're going to take the log base 4 of everything because we're all operating in log base 4. So I like to use a parenthesis. So we're going to take we know we're going to have division. So we have the m to the 4th term times the n cubed term, because they are related by addition, minus the p term, which subtraction correlates with division. So now expressed as a single log, we have the log base 4 of m to the 4th times n cubed over p. Okay, let's keep going here. Example B, we have 3 ln 2 minus 2 ln 5. Okay, so first things, let's take it one piece at a time. Let's convert our coefficients. So we should have the ln of 2 cubed minus ln of 5 squared. And now, since we're operating with actual values instead of variables in our bases, we can actually, we can simplify. So this is going to be the ln of 8 minus ln of 25. And since they're both ln, that is the same log base essentially, because they're both ln, so we can condense them. And how are we going to condense? Subtraction indicates division. So we're going to have ln of 8 over 25, because remember, whatever comes first is in your numerator, divided by whatever comes second. Can we simplify? No. So we leave it as ln of 8 over 25.